Most people are aware that fossil fuels are a finite resource, but of all the sustainable alternatives, they do not want to replace them with nuclear energy. A Google search of nuclear power throws up a number of news related posts, albeit some are positive, reflecting the growing safety of nuclear power. These are mostly few and far between, instead, concentrating on the negative aspects. Finnish nuclear power plant shut down after radioactive leak. To most people, the headline would set alarm bells ringing. But as one delves further into the article, it becomes clear the issue was dealt with swiftly and without many issues. But this isn't the information anyone remembers. If the coverage isn't on danger, it is almost certainly on the cost of nuclear power. The Hinkley Point plant has barely spent a day out of the press recently, since the current deal contains a poison pill which could leave taxpayers with a £22 billion bill if a future government closes the plant before 2060. With the number of abandoned, cancelled, or unfinished nuclear power plants worldwide, around 200, this clause certainly doesn't increase public confidence. Many also think that government money can be better spent elsewhere, which is backed by a recent study that suggests nuclear power as a way of cutting emissions is far too expensive and risks damaging economic growth, and thus leaving future generations unable to pay for technologies used in reducing global warming. Nowadays, so much of the information provided is presented either on TV or in films. Since the Chernobyl disaster in 1986, the haunting images of the power plant have been included in numerous television documentaries and news links. In addition, since the early testing of nuclear weapons in the 1950s, films have focused on the effects of nuclear radiation. From gigantic mutant irradiated ants to Godzilla, both an outcome of nuclear weapons testing. Of course, we know these are just stories, however, the negative connotations will be very difficult to shift.
But what is nuclear power? Nuclear power is energy that comes from the nucleus of an atom. A nucleus is composed of positively charged protons, shown in blue, and neutral particles known as neutrons, shown in orange, and hence the nucleus has a net positive charge. The nucleus is surrounded by negatively charged electrons together making up the atom. There are two ways of obtaining nuclear energy: fusion and fission. The former describes the fusion of two nuclei to form a larger atom. This is how energy is produced by the sun, where temperatures of over 100 million Kelvin overcome the large energetic barrier of bringing together two positively charged nuclei. Because of the demanding conditions required for fusion, nuclear power plants currently only use fission to produce their energy. This process involves firing neutrons at heavy nuclei such as uranium or plutonium, which causes them to split into smaller parts and release lots of energy as well as more neutrons. These neutrons go on to cause other fissions, which release more neutrons, and so on, causing a chain reaction of sustained energy release. If this chain reaction is uncontrolled, then it will cause a huge explosion. So in our nuclear reactors, we use control rods made of materials like silver and boron, which absorb neutrons without themselves fissioning. Nuclear power is generated in nuclear reactors. The nuclear energy released is in the form of heat, which is carried out of the reactor by a coolant. There are many different forms of nuclear fuel and coolants, and hence many types of nuclear reactor. The most common is a pressurized water reactor, which keeps water as a primary coolant under very high pressure so it doesn't boil. The water passes through a heat exchanger, which vaporizes water in a secondary loop to produce steam that drives a turbine. This turning turbine generates electricity just like in a fossil fuel plant. Most reactors are typically loaded with uranium oxide fuel rods arranged in assemblies, whereby 180 assemblies make up the core of the reactor. These nuclear reactors are contained in large steel buildings with hemispherical domes, which are capable of sustaining high internal pressures and prevent any nuclear waste escaping to the environment. Nuclear waste refers to the collection of nuclides left over after the extraction of energy from the fuel. It arises when the absorbed neutron does not cause fission, but rather the transformation to a heavier isotope of uranium, for example, uranium-239. An isotope describes the same element with a different number of neutrons. This heavier isotope then decays to a nuclide that can absorb another neutron to become even heavier, and so on. Some of the heavy nuclides produced can remain radioactive for a long time before decaying into a stable isotope.
Many of the people we asked thought the risks of nuclear power outweighed the benefits. The biggest concern with nuclear power portrayed by the media is safety. Nuclear incidents at Chernobyl and more recently Fukushima have left people concerned about the dangers of nuclear power. Despite both the initial and long-term costs of radioactive fallout, Fukushima and Chernobyl are the only two nuclear accidents in history to have been classified in the highest class of nuclear disaster. The infrequency of nuclear accidents means that it is still possible for the benefits to outweigh the risks. The other concern is nuclear waste. Although the waste is radioactive, it can be safely mixed with glass and stored in enormous cooled solid structures. Perhaps the greatest danger of nuclear power is the threat of it being used as a weapon, or plants being the focus of terrorist attacks. However, nuclear power plants are some of the best protected facilities in the UK, with both physical and electronic protection systems. Not only this, but low enriched uranium used as fuel for nuclear reactors cannot be used to make nuclear weapons. Over half the people we asked thought that nuclear power is not environmentally friendly. Despite the potential pollution hazards of uranium transport and the environmental impacts of mining and purifying the uranium to produce yellow cake, nuclear power is far less polluting than fossil fuel alternatives. Producing power from radioactive isotopes produces no primary greenhouse gases, such as methane and carbon dioxide. Many people underestimate the cost of building a nuclear power plant, which is anywhere upwards of $9 billion. However, this cost includes the expenses of storing nuclear waste and decommissioning the plant at the end of its life. Nuclear power is also 10 times cheaper to produce than solar power per kilowatt hour due to low operating costs of a nuclear power plant and the low cost of the uranium fuel. Uranium-235 is the radioactive isotope used in nuclear fission. Unfortunately, uranium isn't renewable, and there is only 70 to 80 years of uranium-235 left. However, there are fissionable alternatives such as plutonium, which can be made from uranium-238, of which there is at least 10,000 years' supply. Nuclear power also has the benefit over other sources of alternative energy of not being weather dependent. It does not rely on specific wind speeds, tides, or sunlight hours. Not only does nuclear power not produce primary greenhouse gases, but it is also much more efficient than fossil fuels. Weight for weight, fission of uranium produces 10 million times more energy than fossil fuels.
As previously mentioned, fusion requires more energy to occur compared to fission, and is the process by which the sun creates its energy. Hydrogen nuclei collide, fuse into heavier helium atoms, releasing tremendous amounts of energy, greater amounts of energy than nuclear fission, whilst also producing far fewer radioactive byproducts. The ability to produce nearly limitless, low pollution, and non-profitable energy has caused considerable interest in this particular area. Where we get hydrogen for this reaction is a possible issue due to the fact that there is only about 0.02% of natural hydrogen in the form of deuterium, so more needs to be made from the electrolysis of water. Tritium is a radioactive isotope of hydrogen and is formed by the reaction between lithium and a neutron. Up until recently, there have been problems with controlled fusion due to technical problems involving plasma confinement within magnetic fields. The ITER project is looking at overcoming this issue. First proposed at the Geneva Superpower Summit in 1985, with the final design plans approved in 2001, after the EU, USA, Japan, and the Soviet Union joined. Further countries joined, giving a total of 35 nations collaborating on the project based in southern France. Construction started in 2010, and today over 2,000 people are collaborating to build the ITER tokamak. This is a magnetic fusion device in which powerful magnetic fields are used to confine and control the plasma away from the vessel walls. Energy produced by fusion is absorbed as heat in the walls of the vessel. This heat is used to produce steam and then electricity using turbines and generators, just like a conventional power plant. It is hopefully going to produce 500 megawatts of fusion power, designed to produce a tenfold return on energy. However, it is currently costing an estimated 3 times the original $14 billion. There have been some assumptions that the industry is in terminal decline after the Fukushima disaster, as 48 of Japan's reactors remain offline and the nuclear contribution to global electricity has fallen from 17% to 11%, but this may be wrong. According to Dr. Jonathan Cobb of the WNA, there are 70 nuclear reactors under construction currently, the highest number in 25 years, with a further proposed 500 plants. These figures show that globally, governments are trying to address the rising concern of the increasing energy demand whilst reducing the CO2 emissions linked with global warming, and are looking at nuclear power with some considerable interest.
Thank you very much for watching our video on nuclear power.